Welcome to the next, hopefully not, disaster here. This is a Millipede board, and I bought this because you can get an adapter to put this into a centipede cabinet. You can also get a multi-game kit for this, so it can play centipede and millipede. So you call it multipede, like I was just about to say. So I bought this not working, and just as a preliminary check. Well, obviously, since somebody wrote X's on these pokeys that go right here, I put them in my centipede and tested them, and of course they both don't work. So somebody did a harvest job on this, because it's very unlikely that both pokeys would just die at the same time. It's not unheard of, but it's extremely unlikely. As for the failure modes of those pokeys, let's check that out real quick. It's kind of interesting. Also, I did try the baking technique, I guess you could call it, to see if I could make them come back. That was not the case. What do you think you're doing? Alright, so here we go with bad pokey number one. Pokeys do a couple things, like handle keyboard inputs, paddle inputs, but for arcade machines they don't use that. That's mostly for the computers. In this case, it would be controlling random number generation and sound. So in the case of bad pokey number one, and when Centipede has a bad pokey, you'll usually see either no mushrooms or a straight line of mushrooms. That means the random number generation is not working correctly. So you can hit a start game, and we got no sound, so the sound's not working either. Well, one moment. When the spider is present, it is trying to. Also, when you hit a explosion sound effect, it kind of makes a pop. But yeah, that's definitely a bad pokey. So that's bad pokey number one. Alright, so here we go with bad pokey test number two. This one has half the RNG number generation working. Of course, if you put this in like a Tempest board or something like that, where it checks all the RNG as it runs, you'd have a crashy game. But Centipede will display what your problem is pretty quick. It does have working sound though, so I wonder if you got a game that has multiple pokeys and only one is being used for random number generation. You put this in the slot that doesn't have it, and you'd have a working game, because the audio is working. So it's only a partially failed pokey. The other one was much worse. So maybe in Millipede there is a slot that does not use the RNG. So in the case of the Atari pokeys, we have one that's partially good, depending on the board you run it on, and whether it has copy protection that checks both pokeys or not. I'm not entirely sure. You also have the bad one, which does fucking nothing. Then you got Pokey 1s, which is what I'm going to use on this for now. I only have one spare Pokey 1. This is an FPGA replacement for Atari pokeys. I have another one in my Space Duel board that I'm going to pull and put into here while I test this, because I want two working pokeys in here that I know for sure are going to work before I begin testing this. Because it's entirely possible that this was a working board at some point and somebody just had it laying around. They pulled the pokeys out of it, they put it into another game that they wanted to run more, and then decided that they wanted to sell this. So I'm not entirely sure what the exact state of the board is. Maybe we have some bad RAM, maybe, I don't know. I guess we'll find out. I'll have to see if I have the proper edge connectors to hook this up, because I'm going to have to use the scaler and put it on the LCD, because this one does not have composite video out like Centipede did. I'm really asking for it with these old Atari sockets. In order to get this this high score saves kit into here with the Pokey 1, because Pokey 1's a little bit higher sitting than the regular Pokey. I have to put a socket on the bottom of this, and this socket's kind of shit. You can really see that the pins are super thin. I'm really just asking for some connection issues, considering how easy that goes in and out. one of these days I'm going to start having some sort of weird funk that I'm going to go in here and wiggle this while the game's on. It will start working again. I'll be like, ah, shit. So with my current setup, I'm wondering, so this is the Millipede schematics. I wonder, I know that the harness is not the exact same, so I can't just plug in a centipede harness into a Millipede. Some of the stuff will not line up, but I wonder if at least the power will be the same. I'll have to look at that, and if that is, then I should be able to use this right here that I use for centipede, and just power it up with that, and then make the other one so the video comes out of here and goes into the scaler instead of whatever I had. I don't think I even used this connector when I was working on centipede because I just had the composite video out, which this one does not have. But what the hell is 22 volts DC? Where the hell is that going? So we got power input. And what's that doing? It's getting regulated down to 15, positive and negative 15. What the hell is this for? This isn't a vector game. Negative 28 volt supply. Oh, okay, so that's only for generating power for the EA ROM, which stores the high scores, which I don't think we need to have in there to run. On Centipede, I was able to take it out and just leave it out while I was troubleshooting. I think I might be able to do the same thing on Millipede. So it appears that I can use this, but these two bottom wires right here that are for the 5 volts and the 5 volts and the 12 volts, I will not need to hook those up because it doesn't use, negative 5 and 12. So I won't be using those. I'll just be using the 5 volts and ground. However, there's something different about this Millipede from Centipede that turns it into a minor pain in the ass. We got that plus and minus 22 volts DC, which is also on Centipede for the EA ROM for saving high scores. However, since this game can output more colors and the video output's a little bit more complicated, it appears that the color output also uses 15 volts. So the problem is I might not get a video output if I don't hook up 15 volts. And I'm not sure how I can use my other power supply to feed voltage to the same board. I don't know if that's a good idea. So I'm thinking I might put 12 volts on the 15 volts line. And we'll just have a weak video signal. But hopefully that'll be enough to come up on the screen, because we just need to make sure that the computer part of it's working. I'm not too worried about the color output section working properly. So if I put lower voltage on that, I'll know that there's going to be something a little bit funny there. As long as none of the other logic actually uses 15 volts, I think we should be fine. So I figure, since it's only being used for the video output, if I use 12 volts and put it right on the pin here, or the test lug, then it should work fine. The video might not be as hot as it usually would be, but that's fine. I just need to make sure that the computer's working. So we got this all wired up. We got the power ready to go. This one's left unplugged, and I capped it off. This is for the 22 volts. Normally on this board, but it's for negative 5 and positive 12 for Centipede. I got the positive 12 going into the 15 volts here. That's coming from the power supply. And I got my video hooked up to this, so I don't have to solder onto a new edge connector. So I'm going to power this on and see what happens. It'll probably blow up in my face. Dead board. Cool. We got something going on there. It looks like the computer's not running. I don't know if that's a video RAM issue there with those characters changing, but it might be just changing like a bank of memory or something like that. But it is displaying valid characters and it's not garbage, so the video section seems to be working. It's just waiting for the computer to run, and the computer is definitely not running. So, if the computer's not running, these are probably video ROM here. That seems to be working all right. And if that wasn't working, then, if I just pull this out right now while it's on, just start Yeah, they just start losing colors and shit. So, yep. I'm gonna test the game program ROMs now. See what happens. Nice. So with the ROM chips, this reader didn't have the exact model number of these chips here, so I had to go to Google here and look up the data sheet for this specific ROM here. And it says it's compatible with TMS 2532, so if you look that up, I made sure that all the pins are all the same. I can load that up on here. And this is the first ROM. I'm not seeing anything like a dead leg or anything like that. I'm seeing, like, all the letters for, game over and enter your initial and stuff like that. So this seems like it's going to be valid data here. So I'm going to save the buffer here, and then I'm going to dump them all and see if they're all valid. I dumped all the ROMs and they all appear on ROM ident, so I think these are all good, and there wasn't any like obvious patterns with the data being wrong or anything like that. Another interesting thing I see is I have all the ROMs out. If I turn the power on, I get the same exact thing. So there is nothing happening. There is no brainage going on. It's not even trying to run. It's just dead. So what I'm going to do is I'm going to put these back. I'm going to start checking CPU pins for stuck shit. So looking at the pinout for the CPU, reset pin is right here, and it is active low. And right now, it's being held low, so the watchdog circuit's not working correctly. It's holding the CPU in reset, so it's not going to do anything. It's completely fucking dead. So let's see here. What's the clock? Here's one of the clocks on pin 3. We got a clock. That's good. What's clock 2? Clock 0. I think there's... that's all the clocks. So we got clock. We just don't have the reset pin held high to start the CPU. So this game is using all the weird voltages. So I traced it all the way back to the watchdog, and then I traced it back to the power on reset, and it turns out that the power on reset requires the 10.3 volts unregulated from the power supply to start up. So now I got this wire jumping from the 12 volts to the 10.3 on the startup, and if we grab my probe, no, there's still no difference. It's still not running at all. I got an actual watchdog signal going on the CPU, so it's trying to start up. But now we got fuck all. That's what the clock looks like when it's zoomed out really far. This thing's got 3 clocks to it. That's not the clock. Alright, so that means I'm going to have to figure out if there's something wrong here, because it's still not executing any game code. It's still stuck completely. It's not doing fuck all. The CPU could be bad. Actually, for shits and giggles, considering it's not changing garbage, it's not doing fucking anything, I'm going to put a different CPU in here. So now we have the Millipede CPU inside of the centipede that I fixed. Dead CPU. Very cool. If I hit the test switch here, nothing's happening. This CPU is dead. It's watchdogging. The graphics are just kind of doing its thing, waiting for something to happen. So that CPU is dead. So I got 2 dead pokeys, 2 dead pokeys and a dead CPU. So I got the other centipede's processor in here, and it's still fucking dead. So that's 3 big chips dead on this thing. So part of me wants to think that it might have been a power supply failure. It ran the 5 volts too high and killed stuff. But the ROMs are still good. So I'm not going to say that yet. So what else is wrong with this thing? It's so fucking dead. So it's still watchdogging. CPU is good now. Got two pokey ones in there. Got garbage on the screen. There's something preventing the whole thing from running, so let's take a further look. So I spent a good while probing all the addresses and data of all the ROMs and the chip selects that are on the ROMs, and those seem to be working just fine. One thing I did notice, I'm starting to suspect this chip right here. This is the address decoder, and so if it can access the ROMs and the ROMs are good, these buffers for the ROMs seem to be good. I don't have any complaints with their signals. I can't tell you if the logic is wrong with them, but I'm assuming that those are going to be good just for shits and giggles, because I found something that's kind of obvious. Well, even if these were bad and the CPU is just throwing garbage anywhere, at some point it's going to try and write to RAM or address the RAM, which should make this thing enable the RAM. The RAM is right here. These are the RAMs, but the buffer between the RAM and the CPU is right here. So on one side we have the CPU signals, or the data bus on the CPU side. Ignore that one. It's doing shit. You can see it's wiggling and beeping and bullshit, but on the output side, it's mostly floating. And so, for it to not be floating, that's a tri-state chip. Not this one. This is what we're looking at right here. Pin 19 has to be activated, and that's what enables back and forth flow. So this wiggling back and forth is fine, because that just indicates the direction. That's kind of fucking weird. It's mostly stuck high. And if you look at it on the scope, you can see that most other signals are kind of like that. There, let me zoom it in. You kind of look like that. So you can sort of see what like the general like width of like what a signal would be. And you look at that pin again, it's just kind of poking. It's not really doing much of anything. I'm not sure what that's all about, but this chip right here is the one that's outputting that on this pin here. So for some reason, you'd think that it would be trying to address RAM more if the computer is just trying to fucking spaz out. So I'm guessing that chip is bad. I don't have that chip on hand, but on my spare centipede board, it is right here. I'm gonna borrow that. We're gonna see if we can make this thing work. What? Go take your... Oh, ouch. Fucker. Alright, so I got the LS42 chip in right here from the centipede board. We got everything hooked back up, so I'm going to power it on, see if it freaks out. Still nothing. Cool. After some fiddling around, I'm starting to suspect this CPU now too, because if you let it watchdog for a while, I'll poke my probe on here, the CPU inputs start doing fucking nothing. So this one right here, the blue line, is watching the watchdog. That's the reset. And if I just put my probe on any of these address lines, it just stops. Probably no difference, but I put a different CPU in there again. Yeah, a whole lot of nothing different. That's a little bit different now. No, that's not doing shit. That was doing stuff. Get down, you ding dong. What do you think you're doing? So do we have a light bulb fuse or a working monitor? Let's find out. Plug this in. That sounds like a working monitor. Oh, what the hell? Whoa. That does not sound like a working monitor. Well, it is the next day, and I think I finally found a lead onto what's going on. It's still not doing anything. I did suspect this before, so I did change these 3 chips out with new ones. So those are all brand new. However, I also put new RAM in there because that's a good guess. I just tried some very obvious stuff. This I thought was wrong, so I changed it, but then I put this old one back in my centipede board and fired it up, but it still worked. This is definitely bad because I put this into the centipede board and it would not boot with the old one on this, so that was bad. So I've just been trying to figure out what the hell, and I figured out it does have access to RAM at all times. This right here only goes to like outside sources that use the data bus, so I can ignore this completely, which I wasn't before. Because I'm just trying to get the program to even do anything at all, and it's not doing shit. So I was looking at these right here, and those are these 2 chips right here, and what those are, they're just buffers for the address bus. The address bus is always output by the CPU at all times, so that it tells the computer the whole thing overall where it's at. So the address of the buffers right here are always tied to ground on the enable, so that they're always enabled and outputting. So I started testing between input and output, input and output, input and output, until I got to AB3 here, and I was testing 2 and 18, and so the waveform should be the exact same because it's always outputting. However, that's not the case here. So this is the input from the CPU, this is the output from the buffer. You can sort of see that it's trying to do something maybe. So right now my address bus is not functioning correctly, so it is incapable of doing absolutely anything. So I need to figure out what's causing that. Since those are new chips, I can say that those chips are not bad. So there's something else that's hooked up to these lines that's dragging the bus down every so often. So it could be anything hooked up to the address bus, which is going to be a giant pain in the ass, because there's a lot of things on this board that's going to be connected to the address bus. So I'm going to continue going through all the address bus lines here and seeing which ones don't match. So far I know that 3 and 4 do not match properly, so I'm going to try and use some deduction here. So the first 2, I'm going to see if there's like something that connects specifically to the address lines that aren't working, and then try and remove that from the circuit and see if that changes anything. So looking through it, 3 and 4, address bus 3 and 4 on this one specifically is not working correctly. I'm going to look at chips and stuff that are connected to those 2 lines and then see what's going on. Alright, so that chip was definitely bad, and what I had was these 2 lines that were kind of fucked up. So it turns out, after poking around, I tried desoldering this. I tried isolating those 2 lines from each other, but when I did that, I was desoldering this to isolate it, and then I checked with the continuity and actually found out that these 2 lines were shorted to each other. It turns out that solder blob here was stuck in between the pins of the ROM, so when I was changing this out and messing with all this other stuff, I must have got a solder blob onto there. So where does that get us now? So we got the data bus is working correctly, and so I turn it on and I get this now. And that's a very good sign. And it just looks like another screen of garbage, but you can tell that the computer is trying to write to the video memory, and you see that it's blinking and restarting every once in a while. So that's the watchdog. So watchdog is not resetting every 2 seconds or every half second or so. So you know that the game program is trying to run, because without the game programming running, it will just like reset eternally. But something is telling the watchdog to reset its counter or its countdown to reset the game. So it's staying on longer. You can see it's trying to fill the screen with mushrooms here, and then he gets a bunch of G's. And that's actually a very good hint. So, like Centipede, I think the video RAM is in a similar layout. If you want to check out my last video on that, you can see how that works out. Anyway, so I was thinking, with these G's being a little bit different from the mushrooms, maybe it's failing to write to some of the RAM here. So how it works is like a pair of RAM is on like, so the screen is split down the middle. Every line is interlaced to every other line. So from the half here, right here, this is 2 RAM chips. This is 2 more RAM chips. That's the third set. That's the fourth set. That's the first set, second set, third set, fourth set of RAM chips for the screen. So there's something wrong with those, either addressing that RAM or the RAM itself. But this is completely normal behavior. The game program is running. I can open up MAME right here. And so these are the dumped ROMs I got from my board. So I know that these are the ROMs it's reading right now. Watch closely as it starts up. Did you see that? When it starts up, it fills the screen with blue mushrooms. It's trying to do that. So there's something wrong with the video memory section here. So I'm going to get my beeperator and we're going to figure out what the fuck. So doing similar with what I did with Centipede, we're going to try and diagnose the video RAM. I've already narrowed it down to which chip it is that's not outputting correctly. We'll probe it to make sure it's actually dead or something like that. Make sure it's being selected. All that good stuff. So I might have already done this with Centipede and Millipede. I think also with Millipede. The screen is held by 4 banks. There are 4 pairs of chips. And so if we split the screen, each line is interlaced with each other, and then it's split down the middle. So the first line halfway across is by 1 pair. The first line second way across is by the second pair. Second line first way across is held by the third pair, and then the second line the second way across is held by the fourth pair. So 1, 2, 3, 4, 1, 2, 3, 4, and it fails on the fourth bank. So the fourth bank is failing. I can tell it's not addressing, because if it's addressing, this line would fail because this is the same chip as this one right here, and this is working correctly. So I think that the RAM itself is not outputting correctly. So let's see here. Let's go over here, and how do I figure out what chip it is? Well, with MAME, if you go in the test mode, as you can see, just like Centipede, it will dump the entire contents of the graphics ROM to the right of the screen, going from 00 to 256. So what it's drawing is G. What it's supposed to be drawing is that one right there. So this one is decimal 119. This is decimal 7, I think. So if you convert that to hexadecimal, you can see that the G is just 0111, and that's on the lower half, or the lower half of the byte, while the mushroom that's trying to draw is 120 or 119, whatever. Yeah, 119, 0111, 0111. So this nibble here is missing while it draws that, and it's pissing it off, I think. So there's something happening to that data. So what selects between all this shit? So all this playfield memory here is controlled by this multiplexer unit here, and so the game loads data into all this stuff, and then this is right here is what controls which quadrant or which pair of RAM it's going to be reading from at any given moment. And each one of these RAM chips has 4 outputs, so you need to have a pair to have a full byte. So we need to look for the upper half of whatever draws to the fourth bank here. So if you look at it right here, we got this chip. it reads 128H, which turns on after it's halfway done drawing the screen, and then 8V, which turns on, you know, every other row of tiles. So this is what's going to control this line here, which will control these chips, which controls what data is going towards the hardware that actually draws the graphics. So if you look at it, we're going to be looking for the fourth pair of RAM chips when both of these are on. So both of these lines will be high. And it turns out that on each 4 of these inputs, it selects C3 when both of those are high. So these 4 that come from here are the low half, and the 4 that come up here are the high half. And so C3 from the high half, which would be PFD28. PFD28 comes from right here. Whoop-a-doop-a-doop. Chip 4K. So I'm going to replace chip 4K, and we'll see if that clears it up. So I must have messed up with my thinking. I changed this one out, and it did nothing. So I thought this one was the high side of the byte, but it turns out I think this one might have been the high side of the byte. Either that or this one was freaking out in other ways. But now that I turn it on, we got something new. The game's actually running. And so, I think this might be the end of part 1. I'm going to throw the test switch on it just to see. We got things drawing outside of the bounds of the screen, so that's unusual. But those are all motion objects. Also, I don't know what this is all about. I think this should be blanked. So I think the vertical blank, the blanking is not working correctly. Just trying to draw outside the bounds of the screen. This color is that's acting very strange. I'm not sure what's up with that. So let me throw this test switch on there. Well, it does have sound if I look here. I don't have the proper amplifier for this setup, so I can't really get a good audio thing from it, but right now it's running. I'll hit this to start a game, and then I'll poke this onto the my speaker here. So the game appears to know it seems to know exactly where the objects are in computer memory, but the graphics are just drawing to the wrong spot, and also this color corruption here. So that's the last thing I got to deal with. I think that'll just be part 2. I think this thing is about as good as it's going to get for today. And so is the last bit. I started putting old parts back in it. It turns out the only thing that was bad really so far has been the CPU and that RAM there. I put that back in there. That's still good apparently. Even though I put it in the centipede board and it started not working. But I put it in here and it's working, so yeah, I don't know. Bad RAM, bad CPU, something bad going on here with the motion objects. The problem is that if it's not a RAM issue, which it's probably not at this point, there's a lot of counters and stuff in the motion object circuitry that I'm going to have to figure out what the fuck. So, yep, this is going to be a part 2 kind of thing.